When you explode planets, things get red hot. Atmospheres are stripped away. Stuff is flying apart. Everything collapses. The world becomes brighter than a dozen suns. You squeeze your eyes shut and cover your ears. Your hair stands on end. The sheer power of a cosmic blast is terrifying. Some time before the explosion, you're hovering in almost complete darkness. Below, you see the moon, or what you think looks like the moon. The surface of this light-colored sphere is pockmarked with craters left by meteorites. You see huge, steep hills stretching for miles. It's Mercury, and right now, you're going to explode it. As if in slow-mo, you watch the planet fall apart. And then, in the blink of an eye, you see a wall of debris closing in on you. First, giant chunks of rock. Those are all that's left of the planet's solid crust and rocky mantle. The appearance and structure of the debris flying in your direction changes. Now, the stuff looks liquid, like splashes of quicksilver. That's Mercury's metallic core bursting apart. It used to take up 85% of the planet's volume. And finally, it's a firework of solid pieces again. It's the planet's solid core. The explosion is so powerful, it knocks Earth into a different orbit. The sun hiccups and swallows down an enormous cloud of dust. That's everything Mercury has left behind. But don't worry, our solar system won't lose any planets. This whole explosion thing is only a temporary experiment. Once you're done watching the show, you press another button, and the planet gets back together, as if you've hit rewind. You approach the next planet on your way. Its surface is hiding under a super dense atmosphere made up of carbon dioxide. If you decided to land on Venus, you'd watch thick clouds of sulfuric acid pass by. You'd see the planet's surface, reddish-brown, dry, and incredibly hot. You'd probably walk across flat, smooth plains, covering 2/3 of the planet's surface. You'd gawk at volcanoes littering Venus, all 1,600 of them. Unfortunately, you won't be able to do that because you press the button. Boom! Huge chunks of basalt fly away from the center of the explosion. That used to be the planet's 12-mile thick crust. Then you spot bright burning meteors flying towards you at incredible speed. Those are chunks of Venus's molten rocky mantle. The fire rain seems endless, maybe because the mantle was 1,200 miles thick. But that's not the most massive part of the planet. The power of the explosion forces apart Venus's metallic iron core. This core used to be twice as wide as the mantle. You reach the blue marble of your home planet. What will its insides look like, scattered in space? From above, Earth looks pretty. 71% of its surface is blue because of all that water, seas and oceans. There are also areas of green, yellow, and brown and white swirls. You press the button. The planet bursts apart in a hailstorm of rocks. They're what's left from Earth's thin crust and much, much thicker mantle. It used to take up nearly 84% of the entire planet's volume. You see the rocky rain change into something way more liquid. It's scorching hot iron and nickel that used to make up Earth's outer core. The metals weren't under enough pressure to be solid. The bang is so powerful that it takes apart Earth's inner core. It used to be a solid ball of iron and nickel. After the pieces fly apart, they follow their own orbits around the sun. The most massive chunks crash into the moon, and some travel further and get swallowed by our star. You can't linger. The red planet is waiting for you. The surface of Mars is covered with rusty-colored dust. The thickness of the dust layer varies from area to area, but in most places, it's 7 feet thick. The ground is colored gold, brown, tan, and even greenish. The hue depends on the minerals that make up the soil. The planet's surface is rocky. It's covered with dry lake beds, craters, volcanoes, and canyons. Bang! Mars is a rocky planet. You have to dodge mountain-sized chunks of crust made up of volcanic basalt rock. What you see next looks as if you've blown up huge amounts of soft, rocky toothpaste. That used to be Mars's mantle, composed of oxygen, silicates, and other minerals. And then the flying pieces get solid again. It's the planet's core's turn. It was solid, made mostly of iron, nickel, and sulfur. Billions and trillions of fragments of all sizes, from a small moon to pieces several feet wide, get launched in all directions. But only very few parts have enough momentum to leave the solar system. The whole event slightly changes Earth's orbit, and the temperature on our planet goes up by 18 degrees Fahrenheit. You leave rocky planets behind and close in on the first gas giant on your way. It's Jupiter. Thick brown, yellow, red, and white clouds hide its surface. They make the planet look colorful and beautifully striped. You hit the button. This time the view is different. Instead of chunks of solid crust, you see jet streams of gas accelerating from the planet's center. It's what used to be Jupiter's atmosphere, made up of hydrogen and helium gas. In no time, the matter hurtling away to space turns liquid. That's hydrogen changing its form under immense atmospheric pressure closer to the center of the planet. A bit later, the liquid is already a mixture of metallic hydrogen and helium. And finally, something solid. It was probably Jupiter's core, 14 to 18 times the mass of Earth. The gas giant's diameter was about 90,000 miles, but the blast lasts no more than half a second. The explosion of Jupiter is so strong, it evaporates smaller planets like Mars and Earth. The sun remains pretty much untouched. It gets hotter and kinda unstable for a bit, but it doesn't last long. The next gas giant on your way is Saturn. At first sight, it looks as if the planet has a surface. The seemingly solid yellowish-brown sphere is surrounded by layers of clouds. Saturn's trademark rings are awesome and colorful: gray, beige, and tan. They're actually groups of tiny ringlets that are made up of floating chunks of water, ice, rocks, and dust. These chunks range in size from specks to massive skyscraper-sized pieces. While orbiting Saturn, they keep colliding, and larger pieces get shattered. You're surprised to see that the rings aren't perfectly round. They have bends caused by the gravitational pull from the nearby moons. 53 of them are confirmed. Titan, an icy world bigger than our moon and even Mercury, is the largest. What you see looks eerily similar to what happened when you exploded Jupiter. There's only one difference. Saturn's rings break apart, sending rocks and ice flying into space at incredible speed. The largest pieces crash with the planet's moons, wiping away the smallest of them. You see streams of gas, mostly hydrogen and helium, with a bit of methane, ammonia, and water. They're moving at breakneck speed away from where the center of the planet used to be. After that, splashes of liquid matter. That's liquid hydrogen that later turns metallic. And finally, the chunks of the solid core made up of rocky materials. You're looking at a beautiful blue-green sphere of the ice giant Uranus. The planet gets this unusual hue when the light from the sun gets reflected off the planet's surface. Plus, Uranus's atmosphere is mostly hydrogen and helium, with traces of methane gas that absorb the red light. Anyway, bang! This time, it's massive blobs of ice that are hurtling in your direction first. They used to be the part of the planet's ice mantle that once made up 80% of the planet's volume. But why does this ice look liquid? On Uranus, frozen liquid isn't solid like on Earth. Ice is a hot, dense fluid made up of water, ammonia ice, and methane. It's often called the water-ammonia ocean. After the bizarre ice rain, you see solid pieces of the planet's rocky core. It used to be small, no more than half the Earth's mass. Some of Uranus's moons get pulverized in the explosion, and several even get ejected out of the solar system. The explosion also slightly shifts Neptune's orbit. And the last planet on your way, Neptune. It looks blue because of a layer of swirling gas and permanent clouds. No time to linger. Boom! The planet doesn't have a solid surface. That's why, after pressing the button, you see Neptune's liquid mantle bursting. It looks like a water-filled balloon thrown down from the 50th floor. This sends splashes of water, ammonia, and methane ices away into space. It's followed by lava-like remains of the planet's mantle. It used to be liquid, red-hot, and rich in methane, ammonia, and water. That's what's left from Neptune's solid core, made up of iron and other metals. As soon as the Earth is cut in half, almost all living creatures will come to an end. An apocalypse will begin, which has not been shown in movies. The atmosphere is damaged, the magnetic field will change, and the planet's landscape completely alters. But the planet will be completely renewed, and life, like a phoenix, will be reborn from the ashes. A super powerful laser would be needed to separate the planet. Such a laser has to receive energy directly from the sun. The weapon goes into space on a rocket, thousands of miles above our world. Then, once the laser arrives at its destination, it opens wide to expose plates of solar panels. The laser absorbs and concentrates the sun's rays. Then a powerful energy beam with the diameter of several cities shoots into the middle of the planet. Oceans through which the beam passes boil and evaporate from the high temperature. These vapors turn into a vast thundercloud in the sky. A strong wind drives these clouds over the continents. Heavy rain falls, which floods not only cities, but entire countries. As the tectonic plates shift, tsunamis are created. Huge waves crash onto the shore. The Earth is split in two. And this is just the beginning. The structure of the Earth, or rather, each half of it, is changing. Strong earthquakes occur all over the world. The worst disasters happen near the fault line. Billions of tons of ground are smashed. Massive landslides drag entire cities below. Chunks of land, thousands of miles in size, shoot away from our planet. All living creatures on these pieces of land fly into outer space. Other broken pieces of the planet land on the half that is closest to them. Imagine a huge rock the size of a whole city falling from the sky. And there will be hundreds or thousands of such stones. Those who live far from the cut site have a chance to survive. But even there, earthquakes will destroy houses. The moon will also start to throw off pieces from itself. These pieces, like a meteor shower, will fall onto the Earth halves and create massive explosions. These explosions will create fires. The skies will be covered with ash, and until it settles, we won't be able to see the sun. Both parts of the planet are drifting away from each other. The red-hot heart of our Earth is right in the center between the two. This is the Earth's core, consisting of molten metals. Each half of the core exudes energy comparable to a star. Between the two parts of the planet, a layer of such hot space is created that nothing can survive there. Any item that falls into this space immediately turns into ashes. The mass of the core is much larger than the ground mass, so there's a higher level of gravity. The core sucks in everything that comes close. You can't travel from one part of the Earth to the other. The core's gravity attracts any shuttle. Each half of the Earth now lives on its own. Typically, the core inside our planet rotates and creates the Earth's magnetic field. This field is a shield that protects us from the sun and space. If the shield is damaged, solar and cosmic radiation passes through the atmosphere. Because the core is divided into two parts, the Earth's magnetic field becomes unstable. Power outages begin in both parts of the planet. Microwaves, TVs, kettles, traffic lights, computers, everything is broken. The screen of your laptop or phone starts turning on and off. The video may freeze and the battery runs out and charges in 1 second. Satellites stop working, which means there will be no more GPS. High-frequency radio waves used for communication stop working, which means you can't make calls and send texts. In fact, all power plants may sink underground or be flooded because of the earthquakes, so there might not be electricity at all. Some people are sensitive to solar storms and experience severe headaches. When the magnetic field is damaged, the surviving people and animals will suffer from severe migraines. Scientists will have to invent special helmets to protect people from the sun. For full protection, people will have to live in underground cities. Compass needles no longer point north. They just spin in different directions. The birds go mad. They don't know where to fly to wait out the winter because the south no longer exists for them. All animals stop migrating. In the sky, planes can't navigate. Plants and flowers can't grow naturally thanks to the increased radiation from the sun. Livestock are poorly fed. The quality of products deteriorates. There's famine. The main goal for people on each half of the planet is survival. In some places, closer to the fault, the Earth's atmosphere is completely damaged. The conditions there will be similar to those in space. There is no air or heat. Only in a spacesuit can you stay in this territory. Unfortunately, you won't be able to jump and fly because gravity still works. Besides, it's gravity that becomes the salvation of our planet. Both parts of the Earth won't fly away from each other because of the force of gravity. Instead, they will rotate and start to attract each other. In 100,000 years, both parts of the planet will reconnect once more, and the Earth will be completely renewed. Since the core is molten metal, it will return to a single heart, but it will take much longer to connect the solid rock of the halves. A scar forms along the entire fault. The scar will be overgrown with forests and flooded with oceans, but there will be strong earthquakes in some places near this scar. By this time, all living things have probably disappeared. On our planet, conditions are about the same as 4.5 billion years ago. Seas and oceans boil, lightning strikes everywhere, tectonic plates change their shape, and lava flows from volcanoes in a rapid stream. The Earth looks like a vast boiling pot, inside which life is gradually created. Because the Earth has decreased in size and the core hasn't changed much, the gravity will be different. On land, it will be more difficult for an ordinary person to walk. They will weigh much more. In such conditions, new, previously unknown life will be created. Today, the world's atmosphere and oceans are polluted, the population is increasing, and glaciers are melting. In the future, things could be much worse for our planet. In 1,000 years, when humanity has mastered space travel, we may decide to change our residence. We'll start looking for other Earth-like planets, and maybe we'll find something. However, nothing compares to our first home, and humanity decides to cure it. Perhaps we'll come up with the idea to divide the planet in half and live on one side. And after 100,000 years, we can come back to a new healthy home. What if you divide other planets? Since they don't have a magnetic field, they won't be as affected. For example, Venus and Mars have no seas, oceans, or lakes. Some scientists think they're entirely dried up because the magnetic field has disappeared there. This led to the complete destruction of the atmospheres of these planets. The solar wind blew across their surface with such force that it dried up all the liquid. The Earth's atmosphere reflects this wind, so thankfully, we're safe. There would be no significant cataclysms on other planets, except for earthquakes. Like Earth, the two parts of each world would simply rotate until they reconnect once more.
Now, what would Earth look like if it was the only planet in the solar system? Or, what would happen to our planet if the moon went missing? Or, what if dinosaurs had never gone extinct? We've all heard the story. Over 66 million years ago, a big asteroid hit Earth. Almost 75% of creatures that roamed the planet at the time were wiped out in mass extinction. Among them, dinosaurs. Tyrannosaurus, Triceratops, Velociraptor, all gone. But because of that, we're all alive. According to science, the human race was developing more safely without these gigantic creatures hunting us. But what if that asteroid had crashed to the ground a few miles away from the place where it fell? What would the world be like today? Imagine walking down the street to your local supermarket and coming across a truck-sized T-Rex. Could that ever happen in this alternate universe we're talking about? Well, dinosaurs would have had to survive a lot more than an asteroid to be living nowadays. About 55 million years ago, the temperatures on the planet rose. The climate became 14 degrees Fahrenheit hotter than it is today. Rainforests flourished, and vegetation was abundant. In this scenario, herbivore dinosaurs would have likely thrived. But they would have started to look a bit different. Plants started growing during that time period were not very rich in nutrients. This means that dinosaurs would have probably shrunk in size, not having the necessary energy to grow all the way to their full size. Then, about 34 million years ago, South America and Antarctica split, which resulted in a cooler and drier climate. During this period, long-legged dinosaurs would have been the ones to survive. At that time, animals had to travel long distances to hunt, since seasons started to affect the availability of food and water. Compared to the mammals of that period, dinosaurs would have had significant advantages, like having more teeth or better eyesight. And speaking of mammals, some of them probably would have never evolved. That would have become dinosaurs' breakfast first. By the way, did you know that some dinosaurs live among us today? Think pigeons, or birds in general. They've all evolved from dinosaurs. Now, I bet you've heard once or twice that we use 10% of our brains. If this was true, what would happen if you used 100% of our brain? Would you be able to compose a symphony? Would you become a tech genius and create a multi-million-dollar company overnight? Let's start with the facts. We don't only use 10% of our brain. This notion became highly popularized by movies, but it's not very accurate. The truth is, the largest portion of your brain is active at all times. But not all parts are working simultaneously. The exact percentage varies from person to person. Now, neurologists say you wouldn't be using 100% of your brain's capacity at once. Your body simply wouldn't have enough energy for that, which means you'd be hungry all the time. Imagine the number of calories you'd need to consume for that to work. You would also be limited by your body's basic needs: breathing, digesting food, and circulating blood. So if you did use all of the capacity of your brain, you'd be tired all the time. It'd be worse than running a marathon without any preparation. The brain would need all the blood you'd have, which would mean less oxygen for your lungs. Different organs would begin to shut down one by one. In a nutshell, it'd be terrible for your health. By the way, some researchers have estimated that more than 60% of the brain is composed of something that is called neural dark matter. In other words, this dark matter consists of neurons that have no apparent purpose or simply don't respond to common stimuli. Marathons are some of the greatest feats of strength and endurance in the world, but what would happen to your body if you decided to run a marathon without any training? The statistics are overwhelming. Nearly 50% of participants drop out of the race before crossing the finish line. A regular marathon is 26 miles long, and if you're not used to physical activity, it's a great challenge. You'd probably be able to run the first mile without any serious problems, but breathing loudly and heavily through your mouth. By the third mile, your body temperature would skyrocket, and you'd feel as if you have a mild fever. You'd most likely give up here. But if you decided to keep going, you'd have to trick your mind and body into running another 23 miles. By the 20th mile, you'd hit what is known as the wall. Your body would have burned all your reserves of glucose, and you'd get extremely tired. Even experienced runners often go through this stage. By the end of the marathon, you'd be promising yourself to never do this again. You'd leave the race with at least a few cramps and many food cravings. Now picture this. It's a clear, beautiful night. There are no clouds, and you can see two of the brightest planets in Earth's sky blinking up there. Those are Mars and Venus. Now, have you ever imagined what would happen if Earth was the only planet in the solar system? If the other planets never existed, things would be really different for our Earth. The planets in the solar system work together, keeping one another in certain place with their gravitational pull. Now, if Mercury or Venus ceased to exist, Earth would drift closer to the Sun. our atmospheric temperature would become similar to that on the surface of Mercury, 800 degrees Fahrenheit. This would make life on Earth impossible, but if Jupiter or Saturn disappeared, Earth would most likely drift further away from the Sun, and its temperature would drop to below -200 degrees Fahrenheit. If life managed to survive in such circumstances, it would probably be aquatic. The position of Earth in the solar system not only affects all kinds of life forms, but it also dictates seasons, the length of days, and how long one year lasts. Now, when we say no other planets, we mean no moons either. So, what would happen if one fine day the moon just disappeared? That would have catastrophic consequences. The moon has the largest influence on Earth's tides. In a moonless universe, tides would shrink by about 75%. This would greatly affect crabs, mussels, and sea snails that live in tidal zones. This would consequently disrupt the diet of larger animals. Eventually, it would affect entire coastal ecosystems. Earth's weather would change. Tides and tidal currents help mix cold Arctic water with warmer water from the tropics, stabilizing the climate worldwide. Weather forecasting would become almost impossible, and the average difference between the hottest and coldest places on Earth would become extreme. The absence of the moon would also influence Earth's tilt. Right now, Earth tilts on its axis at 23.5 degrees, mostly due to the moon's gravity. With no moon around, Earth's axis would wobble between 10 to 45 degrees. Scientists believe that even a slight difference in Earth's tilt can cause huge changes, such as an ice age. Other than this, a moonless sky would upend the lives of many nocturnal animals. Moths have evolved to navigate using the light of the moon and stars. Newborn baby turtles use the moon's light to find their way to the ocean. Different animals rely on both darkness and a small amount of moonlight to hunt effectively. Now, how about we travel far back in time and imagine what would happen if you lived in ancient Egypt? This civilization lasted for over 3,000 years. Ancient Egyptians were responsible for building some of the world's most recognizable symbols, the Great Pyramids at Giza. If you'd lived in ancient Egypt, you'd have witnessed a time of enormous scientific and mathematical breakthroughs. Ancient Egyptians organized themselves in strict social structures, so you'd probably have to fit into one of them. You'd have either been born a laborer, a farmer, or a specialist, which was either a soldier, a sailor, or a teacher, or you'd have been part of the Egyptian elite. If you had been a farmer, you'd probably live in a house made of mud bricks. You'd have had a stone oven and kept your food stored in a pit in the ground. You'd have spent your days tending to crop fields by the Nile River, or taking care of cattle and ducks. On tax days, you'd have packed up some of your harvest and brought it to the temple as payment for the usage of land. If you'd been a member of the elite, you'd have spent most of your days in banquets. You would have adorned yourself in gold and semi-precious stones, displaying all your wealth. If you had lived in ancient Egypt, maybe you would have been one of those who invented tables. Yep, before the Egyptians, there was no such thing as a table. This invention appeared as a way to keep food off the ground.
Like the little engine that could, NASA's Curiosity rover has been bravely crawling over Gale Crater on Mars, trying to see what could have happened billions of years ago that made the planet a red desert. And it looks like it might have finally stumbled upon something. While life seems impossible on Mars now, eons ago, it may have been a world more like Earth, with a thick atmosphere, water, and maybe even life. And it seems things changed just recently. Studies show that just 3 billion years ago, the northern hemisphere of Mars might have hosted a stable ocean. On Earth, the Archean Eon was in full swing. Volcanoes were going crazy, and life was taking its first steps. Life was also perhaps taking its first steps on Mars. No, not a frozen wasteland like Antarctica, but in a body of water like an Earth ocean. And this Earth-like climate extended Mars's habitable period by about 500 million years more than we thought before. In other words, there was a 500 million years where it was exactly like Earth, with conditions just right for life to start forming. But then, something happened that changed things forever. The atmosphere thinned, Mars lost its oceans, and became the cold, desolate place we see today. It's been a mystery for a while, but now curiosity stumbled upon something interesting in the Gale crater, a vast basin on the Martian surface where billions of years ago water once flowed freely. It found carbonates, stuff that can tell us all about the ancient Martian climate. There are minerals that form when carbon dioxide, or CO2, dissolves in water, which means that, to create them, you need two things: a nice thick atmosphere and liquid water. Now on Earth, CO2 is super important because it helps trap heat from the sun in our atmosphere. This keeps our planet warm enough to support life. Plants eat it during photosynthesis to create oxygen, which humans and animals need to breathe. On Mars, the presence of CO2 shows that there really was some kind of climate system. When CO2 starts dissolving in water, it reacts with certain minerals in the ground, like calcium or magnesium, and creates carbonates. That's kind of how seashells form in oceans here on Earth. But instead, it's happening with rocks on Mars. And this discovery is huge. These carbonates act like fossils of the planet's ancient climate. They store information about what Mars was like long ago. By studying them, scientists can get a peek into Mars' past back in the day when water was present. They can tell us how the Martian atmosphere has changed over time, show whether the atmosphere was warm or cold, or if there was a lot of water around, and what happened to the planet in general. Luckily, Curiosity can study this stuff right there. It has the sample analysis at Mars and tunable laser spectrometer. Those are like Mars's forensic tools. The SAM is a mini lab on wheels, and it's capable of heating Martian rock samples to extreme temperatures. There are two ovens that can heat samples to about 1,800 degrees Fahrenheit. This intense heat causes rocks to release gases trapped inside, the ones that are like ancient fingerprints of Mars, atmosphere. Once they're released, the TLS analyzes them in detail, breaking them down to the tiniest parts. And what the scientists discovered blew away all our previous assumptions about Mars' habitability. Turns out, it's not just about Mars once being wet, but there was something that led to the gradual drying and cooling of the planet. In other words, Mars's water didn't just disappear. It evaporated quickly under extreme conditions. So, what happened to it? Astronomers produced two possible explanations. The first one says that Mars went through periods where it was sometimes wet and sometimes dry. The water didn't last a long time. It may have appeared in short bursts, with periods where it would dry up and then return. The second possibility is more intense. The water that was there was incredibly salty and cold, so instead of being liquid, it was mostly frozen in ice. This would have made the planet way too harsh for life as we know it, since the conditions would have been too extreme for anything to survive. Both possibilities sadly mean that Mars wasn't cozy and full of life in the past like some hoped. Well, at least not on the surface. That doesn't mean underground life couldn't exist though. This one is still a possibility. And to find more, we must keep looking for hints of water now. Actually, after years of exploring Mars, scientists have just made a mind-blowing discovery. Deep beneath the rocky surface of the red planet lies a hidden reservoir of liquid water. Real water this time, not the frozen ice caps or vapor in the atmosphere, though it's miles below the Martian crust. This breakthrough comes from data collected by NASA's InSight lander. This guy spent 4 years listening to the subtle tremors of Mars. You know, Mars quakes. And it analyzed over 1,300 of them. Thanks to this, scientists were able to map out how seismic waves move through the planet. And it revealed pockets of liquid water buried 6 to 12 miles underground. Not just one lake, but puddles. So they used the same methods we here on Earth use to find underground water, oil, and gas. And they were able to piece together the Martian underground system. You see, as the water disappeared and dried out, some of it escaped into space when Mars lost its thick protective atmosphere. However, this discovery shows that much of the water didn't disappear. It just sank deep underground, where it still lies today. So close, but out of reach. That's a huge step forward. Water is the most important molecule when it comes to shaping the destiny of a planet. And also, Even though we said that Mars wasn't filled with life before, this doesn't take away the possibility of it having life now. If liquid water still exists deep underground, could there be some little microbes hiding there as well? Life as we know it can't survive without liquid water. And now, with this, the idea of life on Mars has become more plausible than ever. There's a catch, though. While this water may seem like a jackpot to future Mars colonization plans, it's not going to be easy to reach. To say that drilling 6 miles deep into the crust is no small feat is an understatement. Just so you know, here on Earth, the deepest we've drilled is about 7.5 miles. It was in the Kola Super Deep Borehole project. And this project pushed current technology to its limits. Intense heat, pressure, equipment failures, you name it. With Mars, that would be even crazier. It has a much colder environment, extremely thin atmosphere, and lack of infrastructure. That would make any drilling mission extremely difficult. To reach water reservoirs buried so deep on Mars, we would need specialized drilling equipment that would somehow get delivered there. It should also be able to handle extreme cold, low pressure, and different gravity. Oh, and it should all operate remotely and preferably not break, all while it needs tons of energy. Yeah. Now, it's possible that we would only be able to do this in the future when we'll have automated systems or astronauts on Mars. That's not a quick task for even the most ambitious billionaires. So, for now, what these reservoirs hide is a mystery. But at least it's not the only one. As we mentioned, Mars hides one of the greatest secrets beneath its frozen southern pole, another buried vast lake of liquid water. The radar revealed it as it scanned the ice cap in this region. Hey, just don't make me pronounce it. Now, it's weird that it managed to stay liquid with such low temperatures. It's probably because of the geothermal heat beneath Mars' surface, and life could be there too. So now they're thinking about probing this lake first. That would be much easier. Curiosity's work is incredible, and it keeps helping us peel back the layers of Mars' ancient climate, giving us new pieces to the puzzle of what happened to our neighbor, and this could help us avoid similar mistakes in the future.
About 8 billion inhabitants of planet Earth found out the same terrible news in one day. Someone saw it on TV. Others heard it on the phone while scrolling through social media or listening to music. Some witnessed this news in a dream while sleeping. Someone's voice said it in all languages to ensure everyone understood it. I have good news and bad news for you. Let's start with the bad news. You're all characters in YouTube videos in which your planet gets into a situation where the moon breaks in half. For the audience, it will be a hypothetical story, but for you, these events will become a reality. The good news is that I was joking. There is no good news. But don't worry, the apocalypse won't start on your planet. Maybe just a little bit. Have a nice day. At first, the entire population panics. Then, a few days later, everyone calms down. Maybe it was a mass hallucination, and the moon will be all right. But at this moment, scientists have discovered the danger. A colossal meteorite is flying towards us from the distant depths of space. This meteorite is super fast and pretty flat, but has sharp edges. Fortunately, it will miss the Earth by a few thousand miles, but the moon won't be that lucky. The meteorite flies through our Earth's only natural satellite directly in the middle. So it passes through the moon, sweeps past our planet, and flies away into distant space. At this moment, all people can't take their eyes off the moon. The meteorite cuts it perfectly in half, gently, clearly, painlessly. So, what shall we do now? Will the Earth survive this? Our satellite breaks into 2 equal parts, but fortunately, they don't fly away from each other. The moon's great gravity attracts them back like a magnet. Scientists are sure that the parts will connect in a couple of billion years, and the moon will become the same as it used to be. But the coolest thing is that people won't feel any changes. Everyone around the world will celebrate this good news. The voice was wrong. But then, another problem appears. A massive meteorite in the form of a shoe is flying from the deepest space to us. It enters our solar system and approaches the Earth at high speed. The space boot crashes into one half of the moon and then flies away. Now, the moon is definitely breaking into 2 parts. The first half remains in the same place. The second one is flying towards us. A small meteor shower begins on Earth because of the falling moon fragments, but it's not so bad. Most of these rocks are burning up in the atmosphere. But almost the entire split-off half is falling apart around the orbit of our planet. It forms a stone belt. Now the Earth is like Saturn. Rotating fragments destroy part of our artificial satellites. Communication and the internet work inconsistently. It takes people a couple of years to restore a stable connection. The International Space Station no longer exists. Luckily, all the astronauts managed to return to Earth before half the moon got to them. So, moon rocks are flying around the planet, and people see half the moon in the sky. Life doesn't change much for the first few days, but those who live on the coast of the seas and oceans notice the consequences. The moon used to influence the tides. It was flying around the Earth and made oceans take an oval shape. There were tides on the side where the moon was closer. There were ebbs on the opposite side. But now, this schedule is wrong. Half of the moon attracts less water. Yes, the moon lost half its weight and began approaching the Earth. But its gravitational force has become weaker. Seabirds, many species of fish, sea turtles, and other coastal animals may not survive these changes. Their natural instincts associated with the moon help them determine the time for getting food, breeding, and flying south. For example, tiny turtles expect a strong tide in the morning. They run to the water, but the water doesn't reach them. Turtles can't hide in the ocean in time and become dinner for seagulls. Crabs can't lay eggs because the tide has started earlier than usual. Wolves go mad in the woods. They howl loudly every night and can't stop. The whole natural world can't understand what's going on. The human body is also feeling some discomfort. Many people have low and high blood pressure, and some experience severe headaches. Half of the moon changes the entire ecosystem of the planet. Adapting to new conditions will take several tens, maybe hundreds of years. A couple of weeks pass, and people notice the days are now shorter. The moon always slowed the Earth's rotation and made one day last 24 hours. The Earth is spinning faster now. The night and the morning come earlier than everyone is used to. Earth rotation speed has increased and reduced the number of hours per day to 15. People suffer from insomnia or oversleeping. The body needs time to get used to it. Work schedules are changing all over the world. Previously, people came to the office at 9 and left at 6. Now, they arrive at 7 and leave at 2 p.m. Sleep time got shorter, and people are really sad because of this. Progress slows down because the short working time. The technologies of the future are now 20 to 30 years late. Hourly pay remains the same, so bosses now pay less for fewer working hours. The whole moon stabilized the weather and climate on the planet. Look at Mars. It has 2 small moons. They quickly spin around it and rock Mars around on its axis. As a result, strong winds, sandstorms, and thunderstorms often happen on the red planet. Now the half of the moon that approached us takes the Earth out of stable rotation. This changes the seasonal temperatures in the world. It even gets hotter in hot places. And snowstorms are raging in cold regions. There are short, massive downpours instead of sunny weather. A typical breeze can grow into a hurricane and small waves into a tsunami. The seasons are changing faster now. Winters are colder and summers are hotter. Changing the rotation of the planet affects the Earth's magnetic field. Since the compass and navigation systems are unstable now, we need to recalculate where the north and south are. Birds can't fly south to wait out the winter since they don't know what direction to fly. Their inner compass is broken. Several hundred years have passed. People are entirely accustomed to the new conditions on Earth. New species of animals and fish have appeared. Birds can navigate the sky by the moon again. The planet's economy has been restored. Hourly wages have become higher. People now get enough sleep from 5 to 6 hours a day and work for 4 to 5 hours. The reduction of day and night has also affected the entertainment industry. Movies now last 1 hour. One episode of some TV series lasts 30 minutes. Life goes faster. An average person now lives to be 96 years old. In fact, the passage of time hasn't changed at all. Its calculus did. Several thousand years have passed. People look different now. Now they have big eyes that absorb more light. Half of the moon doesn't shine as bright as the whole thing, so the nights have become darker. It took the human eye a couple of thousand years to develop the ability to see clearly in this new dark. Animals need to navigate better in these conditions, so their eyes have become larger and more sensitive. During all this time, people have cleared the orbit of moon rocks. Several space stations fly around our planet. And again, people hear this strange voice that once told them that they were all characters in one hypothetical YouTube video. This time, the voice says, "Your story ends because the video ends. I'm sorry. Good night."
It's becoming colder by the minute. The temperature drops below zero very quickly. And although there's no snow, the cold is becoming unbearable. Hoarfrost appears on the ground, the grass, and the trees, and ice forms on bodies of water at an incredible rate. Shivering people all over the planet raise their eyes to the sky, and their jaws drop in disbelief. The sun has become twice as small as it used to be. It now looks like a distant speck, and it won't be able to heat the Earth any longer. But the worst thing is, there's a huge blazing rock coming right at the horrified spectators from the sky, and the impact with that thing will undoubtedly do a lot of damage. Okay, let's go back to our objective reality. The Earth is exactly in the sweet spot of our solar system. It's neither too close nor too far from the sun, making the temperature on our planet not just tolerable, but rather pleasant. Scientists often call Venus, the second planet from the sun, our Earth's evil twin, because it's so hot and inhospitable that no life is possible on it. Of course, there are thick clouds in its atmosphere that rain acid, and the greenhouse gases raise the temperature on the surface to unbearable values. But even if Venus didn't have those, nothing would still be able to live there because of the proximity to the sun. If there was any liquid water, it would evaporate too quickly, leaving life no chance to develop. On the other hand, Mars, going next in line after Earth, is a bit too far away from the sun, which makes it cold and lonely. The temperature on its surface is below freezing, and it never warms up enough for water to stay liquid for long. That's not to mention the lack of atmosphere on the red planet, the element that provides the Earth with breathable air. So, if our planet shifted closer to or farther away from the sun, its temperature would either rise or fall respectively. A few hundred miles wouldn't make much difference. The circling of Earth around the sun is uneven anyway, and we constantly get nearer to our star or fly a bit away from it. The distance that would matter is measured in millions of miles. And yeah, just like I showed you at the beginning of this video, we'd see the sun a lot smaller than we do now if we went that far. The temperatures might not fall at the exact moment of the shift, as there would still be some warmth left. But in the following winter, our planet would probably stay cold forever. The oceans would be covered with ice, and the overall sea level would drop. And ultimately, the ice would reflect more of the sun's heat back into the atmosphere and space, not allowing the surface of our planet to get the necessary warmth. And more ice means less water vapor in the atmosphere. Water vapor captures heat too, creating clouds. So the colder it is, the less rain. The cold and the lack of rain would not let any plants survive for long. So the areas of icy and barren landscape would grow fast, leaving only the areas along the banks of rivers intact for a while. After some time, the rivers would stop running too, either frozen or dried out because of losing their sources, lakes and seas, which would, of course, freeze as well. Any life dwelling near them would disappear. Plants first, and with them, everything else, since plants produce both food and breathable air. And with that, the Earth would become a frozen wasteland. As for the giant blazing rock I mentioned, it was an asteroid coming from outer space because of the shift of our planet's orbit. Jupiter, the largest planet in our solar system, acts as a natural shield for us against space rocks. It has a huge mass, and most asteroids flinging from outer space get caught in its gravity and fall on its surface. There's no life possible on Jupiter, and its surface is gaseous, so asteroids tend to disappear in it without a trace. Still, some manage to get past Jupiter, where Mars comes into play. It also contributes to our defense by holding the asteroid belt between itself and Jupiter in place. The two planets' combined mass creates a gravitational field that doesn't allow the asteroids from the belt to fly in random directions, hitting everything in their path. If there was no Mars between us and the belt, we'd be used to meteor showers almost more than actual rains. Say the Earth has replaced Mars in its orbit, and now we're hundreds of millions of miles farther away from the Sun. The mass of the Earth is more or less similar to that of Mars, so the asteroid belt is still in its place. The temperatures will still fall though, and life will soon go extinct. But if Mars stayed where it is, and the Earth just shifted away, it would be a recipe for disaster. There's no chance the planets would orbit the Sun at the same rate because their mass is not equal. At some point, they would collide with each other. Taking their speed into account, they'd both crack and shatter, perhaps creating another asteroid belt in our solar system. It would be no more hopeful for us if the Earth decided to jump closer to the Sun. Apart from the stars seeming more like a giant, pitiless blazing ball in the sky, its heat would melt the glaciers on our planet, making sea levels rise abruptly. The water would flood major parts of the continents, and more surfaces of the planet would be covered with water, which means more heat absorption. That would bring about a further rise in the temperature. Also, those large bodies of water would evaporate like crazy, releasing tons of water vapor and carbon dioxide into the atmosphere. Carbon dioxide is a greenhouse gas that absorbs heat, and so does water vapor. Together, they would trap more and more of the sun's warmth, creating thick, roiling clouds in the sky, almost like on Venus, but without the acid. And that thick blanket of clouds would also contribute to heating the surface of our planet. In the end, the entire Earth would heat up so much that life on its surface would become unbearable for most. Only the sturdiest of creatures would be able to survive temperatures so high. Those that dwell in our deserts, for example. Despite the rainfall, which wouldn't cease as in the cold scenario, plants would still have difficulty adapting to the new and hot environments. The ones in the cooler regions of the planet would be the first to wilt and go. But then, plants from the moderate and finally tropical climes would also give up. And, yet again, the Earth would turn into a barren ball of rock, only this time an overheated one rather than frozen. Our planet's distance from the Sun, its tilt, its speed of rotation around its own axis, its orbit around the Sun, and even the presence of the Moon in its skies, all of that is crucial for life on Earth to exist. For instance, if the planet wasn't tilted relative to the Sun, it would be unbearably hot on the equator and impossibly cold at the poles. The seasons would also stop changing, dividing the Earth into strips of endless summer and winter. Our planet is heated up evenly from all sides with the current tilt and rotation, like you would roast a barbecue. It turns to the Sun with one side to warm it up, while the other cools down during the night. Were there no change of night and day, we'd probably only live in some areas of our planet where constant, never-ending twilight would be. Just imagine our life without those beautiful sunrises and sunsets. Maybe we'll just let it stay as it is, okay?
Imagine you're stepping on board a once-in-a-lifetime Arctic expedition that departs to the east coast of Cape Bathurst in Canada's Northwest Territories. It's said that the location you're headed is unmatched on planet Earth. The final destination is an unbelievable location known as Smoking Hills. These red-striped rocks have been burning there continuously for centuries. It has minerals there that are only found outside our planet, on Mars. Some scientists even believe that the site can be an important case study for discovering life on the red planet. On board the small cruiser ship, you head out to the deck and spot an unusual scene on the horizon. You see clouds of smoke forming close to a seaside hill. It's as if a party of hundreds of people did campfires all at the same time. But this smoke is not man-made, your guide tells you. Naturally, most people guess it's a volcano. Some people on the deck even guess that an eruption might happen anytime soon by the looks of it. Your guide laughs, explaining that this is far from the case. Volcanoes are usually found on the edge of tectonic plates. It's a rupture on the crust of the Earth that allows hot lava and gases to escape to the surface. In the smoking hills, the story is different. The constant smoke is caused by a natural phenomenon. But you'll learn all about it over the next few days. As strange as it may sound, these rocks didn't begin burning yesterday. According to experts, the ground on smoking hills has been releasing clouds of smoke for at least a couple hundred years, non-stop. You heard it right, but experts are still unsure how long they've been burning. It could be thousands of years. Now, before you leave the ship, some instructions are in order. The expedition leader explains you're going to enter a high-risk place. So, we replace your regular hiking boots and clothes with a special suit and gas mask before stepping on site. The clouds of smoke you are now watching from a safe distance are composed of sulfuric acid. This chemical is highly toxic. You need to be careful while breathing its air. So remember to keep those masks on. Oh, and as tempting as it may look, don't touch anything with your bare hands. Legend says that the first crew to explore the smoking hills found it by mistake. And imagine, these people had none of the gear you're going to use. First written records on the smoking hills date back to the 1800s. Irish explorer Captain Robert McClure led an expedition to find the lost explorer Sir John Franklin and had disappeared for over 5 years. The crew took a wrong left along the way and stumbled upon these burning rocks. They also thought it was an active volcano, much like you did, but they discovered how wrong they were when they stepped on site. McClure got curious and took a sample rock back to the boat, and the story says it burnt a hole through his mahogany desk. Remember this when you feel like taking a souvenir home with you. It might not burn a hole on your desk, but it sure will fly through your pocket or any container you try to use to take it. Now, it's day 2, and you're ready to explore the location. The expedition's crew is divided into smaller boats. On your way to the shore, you notice a group of animals. They are far from the smoke, and it looks like they have themselves a mealtime. The smoking hills are located in the Arctic tundra, and there are rich fauna and flora nearby. Slowly, you're approaching the shore. Now you see the cliffs are made of red striped rocks that look like they've been hand-painted by someone. There's another place on Earth with similar hills, and it is located in Peru, all the way to South America. The so-called Rainbow Mountain or Seven-Colored Mountain is a mesmerizing natural phenomenon. They are formed by the sediment of different materials. While the smoking hills are mainly red, over in Peru, these mountains have stripes of lavender, gold, red, and even turquoise. When you finally leave the boat on the foot of the smoking hills, you begin your hike up. Stepping is difficult with your special boots. The soles are made specially to support high-degree temperatures, but it sure is hard to keep your balance. Before you know it, you're as close to the burning rocks as you can get. Your first impression is to get out of there as fast as possible. Conditions for human life are harsh over there. It's inhospitable, and everything about the place says you shouldn't stay for long. But you are also beyond curious. You might ask yourself how these rocks keep burning for so long. The science behind it is not too complicated. The rocks you're looking at are called shales. They are a type of sedimentary rock formed by clay minerals. Your guide explains that the secret to the smoke lies on the ground. The soil is formed by sulfur and coal. When they get in contact with oxygen, they spontaneously ignite, releasing the smoke you're now seeing. The few ponds in the region have very acidic water. Scientists say that this world region is the only one to show a negative pH. It means this water is naturally corrosive, so you don't dare drink it. Make sure to bring your own water bottle when leaving the ship. You spend a few hours there, but it seems like a whole day. The suits are heavy, and breathing through a gas mask is not your idea of comfort. At the end of the day, you head back to the ship, enjoying a beautiful Arctic sunset on the way. On the morning of your third day, you're in for a nice surprise. You're not heading out again. Instead, you're going to take a trip to outer space. Metaphorically, of course. Your guide talks about the connection between the smoking hills and Mars. Looking for life on Mars has been a journey all on its own, but recently, scientists discovered the exciting presence of jarosite on the smoking hills. And guess what? Jarosite is an abundant mineral on Mars. Experts think that this may indicate that Mars did have running water at some point in the past, since jarosite needs groundwater to form. This huge discovery may take science many steps closer to a breakthrough. Has life really existed on other planets in the solar system? Mars has been on the map for scientific research for being the most likely planet to have developed life. The atmospheric temperature now is unbearable for above-ground life, but it was similar to Earth's at some point. The most important proof needed is to find the evidence of running water. Right now, as we speak, the Curiosity rover is out there looking for any piece of information that can hint at the existence of life on Mars, past or present. Just out of curiosity. Curiosity, the rover I mean, has been exploring the surface of Mars for over 3,566 days so far. If you do the math, it makes for 9 years and 279 days. And in case you're wondering, why are we so eager to find life on other planets? According to NASA, the research for life on other planets can help us explain a lot about our own history. Where we came from, and maybe even where we're headed. And who could have guessed that scientists could begin to find answers for that in the Arctic tundra? That's exciting, right? Now, it's day 4 aboard the ship, and the expedition is coming to an end. Time to head back to mainland Canada. You just visited one of the world's most inhospitable places with a lot of impressions. Now, it's time to tell us what you thought about the journey and what you learned along the way. Write it all down in the comments below.
You're in the middle of the Sahara. You see a huge awning with a red target pattern. Its surface is so hot you could fry food on it. A drop of water is to hit the center of this target at the speed of light. Theoretically and technically, this experiment is impossible to conduct. But if it happens, then mysterious nothing awaits us. And each version of this nothing will be different. So we'll do 3 drops. Option 1. It's better to do it from a great height or space. You take off on a jetpack into the stratosphere. You have a bottle of water in your hand. You pour out 1 drop. Let's say it starts accelerating itself. In this case, even at a low speed, a drop of water will burn up in the protective layers of the atmosphere. In less than a second, the drop will turn to vapor. Let's say our planet had no such protection as the atmosphere. The air resistance would still get rid of the drop. The drop is flying down at a tremendous speed. The cold wind turns it into an icicle. The greater the drop velocity is, the stronger the air resistance is. The drop is moving faster and faster, soon reaching the speed of sound. Then, it just smashes into thousands of small particles. Under such conditions, the drop will never be able to reach the Earth at the speed of light. Nothing happens because nothing gets to the target. The next attempt involves changing the drop. Oxygen, carbon dioxide, ozone, and other gases in the atmosphere destroy any falling object. But what if the drop didn't meet all these obstacles? You change the internal structure of water chemically. So, you put your jetpack on again and grab a bottle of water. At the height of the Earth's orbit, you open it and pour out 1 drop. It accelerates and there's no resistance. It passes through the hottest layers of the atmosphere, but doesn't burn, passing the freezing temperature, but doesn't freeze up. It flies to the ground, developing the speed of light, and crashes again. But nothing happens. The drop got the properties of a light particle, a photon. It's only under such condition that it might develop the speed we need. No object with mass, be it a car, a house, a tree, an ant, a single air, a grain of sand, or a molecule, can reach the speed of light. Only light particles are capable of it since they don't have mass. An intangible drop falls into the center of the target, and again, nothing happens. The third option. Scientists found a way to accelerate a drop to the required speed. They also have to change the molecular composition of water, making it more resistant to high and low temperatures. To make the drop reach the speed of light without any damage, you need to place it in a perfect vacuum. No air resistance, no protective layers of the atmosphere. We leave only space and the water. For this purpose, scientists need to build a long pipe. In the center of the Sahara, around the same target, people create a scientific center. From here, the pipe should go up. Its height is approximately the distance to the International Space Station. That's 254 miles, which is about the height of 50 Everest mountains. You can't connect to the ISS itself as it's moving all the time. It revolves around the Earth, completing one revolution in 90 minutes. That's why astrophysicists and engineers should build a small station designed for one person, and this station should move parallel to a single point on the ground. The vacuum tube is made of solid stainless materials so that rain and high temperature couldn't destroy it. Inside, it's an alloy of titanium and graphene, the most durable metal on Earth. The pipe is built horizontally. Then, with the help of several helicopters and cables, it's placed in an upright position and attached to a small space station. The pipe is equipped with small pumps that pump the air out and block its flow inside. The water drop shouldn't touch the walls, so there's a special layer of gravity plates. They push the water away from the pipe's surface, using the power of magnetism and sound waves. You put on a jetpack and fly to the station with a bottle of upgraded durable water. Your hands are shaking with excitement. Your breathing sounds loud in the spacesuit. You open the bottle, tilt it slightly, and pour one drop into a special box. Inside this container, the drop gets charged with the energy needed to develop the speed of light. Now it's ready for the journey. You look at the box, close your eyes, and press the start button. The drop flies into the pipe at a great speed. From the powerful blast wave, the entire station is thrown to the side. The drop accelerates, and at this point, the pipe made of the strongest metals on Earth begins to melt like ice cream. There's so much energy in the water now that it would be enough to provide electricity to a small city. And now the drop reaches the speed of light, which is 186,000 miles per second. The pipe turns to dust. It doesn't matter whether the drop hits the ground or not, because there will be nothing. Literally all material objects, cars, houses, fields, oceans, computers, planes, ships, flowers, trees, should I go on, will disappear. Intangible things, such as gas, air, radio waves, electromagnetic radiation, billions of terabytes of digital information, all this will also be gone. Boy, are you in trouble. Any sound, shouting, music, the phone ringing, will be impossible to create and hear. The light will disappear, and then there will be complete darkness. But let's rewind time and see exactly what happened right now. It won't work, though, because there's no time either. Imagine time as a stormy river that flows rapidly in one direction. Then this river falls into an endless pit and disappears completely. All this happened because a drop of water crashed into our planet at the speed of light. As soon as a drop begins to approach the needed speed, it loses its properties of water. It's now the most powerful and heaviest object in the universe. The energy that comes from it destroys everything for hundreds of thousands of miles. Concrete, ground, rocks, etc., 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 and on and on and on. Everything disappears. In the first second, it all gets shattered into millions of tiny pieces. Then these pieces are torn apart into millions of even smaller particles. The molecules burn up. Imagine a paper map of the world. If you wet it and tear it, it will turn into wet paper scraps. If you burn it, then part of the map will turn to ashes, and the other part will simply fly into the air in the form of smoke. The map will remain, but it will never look the same. But if you destroy the map's molecules, it's safe to say that the map never existed. There's no trace of its existence. The same thing happens to our planet. The energy coming from a drop of water makes the Earth never exist in space. And now the drop exceeds the speed of light. A black hole starts evolving. It expands and absorbs all the space debris. Then the Moon. Soon it will be the turn of Mars and all the other planets in our solar system. The black hole expands and increases the force of gravity inside it. Together with our planet, it absorbs light. It's getting closer and closer to the Sun. Our star splits into strips of light as if it had passed through a huge cosmic shredder. The sun explodes and spits out an impossible amount of energy. It's believed that black holes appear after the explosion of stars. Right now, all the solar energy is being absorbed by our black hole. It's getting pitch black. The light from distant stars falls directly into the supermassive infinity. Meteorites flying within a radius of hundreds of thousands of miles around are also devoured into the unknown. There are many black holes in space, but only one of them was created by a small drop of water. The higher the speed of any object, the heavier it gets. Mass is the amount of energy that an object has. When water molecules reach the speed of light, their mass begins to grow, and there are no limits to this. It becomes infinite. An infinite mass forms a black hole. It absorbs everything, and nobody knows what's inside the black hole. All that remains is darkness and the unimaginable force of gravity. So I'm guessing here that we probably should not be doing this experiment, should we? How about we make a baking soda volcano instead?
Ah, space, the final frontier. It's a vast and mysterious expanse that has fascinated us for centuries. But as much as we've learned about it, there are still plenty of things that we've been lied to about when it comes to space. Let's take a look at some of the biggest lies we've been told about this topic. First off, we have the idea that space is just this pristine, untouched wilderness. But that's not exactly true. We've been littering space with our debris for decades. Everything from old satellites to rocket parts. In fact, there are over 20,000 pieces of debris orbiting Earth right now, and they're causing all sorts of problems for future space missions. So if you're planning on visiting space anytime soon, watch where you go. You never know what kind of garbage might be floating around. Did you know that the sun is not actually yellow? It's green. Well, kind of. You see, scientists measure the temperature of a star by the color spectrum it emits. Cooler stars appear red, while the hottest of stars look blue. Our sun emits most of its energy at a wavelength that's close to green. But because it emits other wavelengths too, all these colors mix together, and your eyes see this vibrant mixture as white. From Earth, however, the sun looks yellow because our atmosphere is really good at scattering blue light. If our star was actually yellow, Earth would become a frozen rock, and we'd all be polar bears. Plus, the sun isn't on fire for real. It's a big ball of gas, mostly made of hydrogen and helium, and it works more like a gigantic nuclear reactor, constantly fusing hydrogen atoms to create helium inside its core. This process releases enormous amounts of energy. That's why the sun is so hot. Oh, and speaking of setting things on fire, explosions in space aren't real. Sorry, Star Wars fans, a spaceship can't go down in a violent blast because there is no air out there in space. No air means no oxygen, and no oxygen means no fire. Now, you might also think that there are too many stars in the night sky for you to count, but in fact, you can do that. According to the Yale Bright Star Catalog, there are 9,110 stars that you can see from Earth with the unaided eye. So, technically, you can count them, but I wouldn't be surprised if you lost count. And if you're worried about flying through an asteroid belt, don't be. Although it does have trillions of space rocks that range in size from space dust to a quarter of the size of the Moon, they're very spread out. The asteroid belt between Mars and Jupiter is 140 million miles across, which is 1.5 times the distance between Earth and the Sun. This spreads space rocks thousands of miles apart, making it almost impossible for a spacecraft to collide with one. You'll instantly freeze in space without a suit. Nope, you won't turn into a popsicle right away. It's gonna take a bit longer than that because heat and cold don't really move very quickly in the vacuum of space. But unfortunately for you, there's a bigger problem at hand. You won't be able to breathe. After just 15 seconds, your brain won't be getting enough oxygen from your blood, and you'll pass out. And then after just 2 minutes, it's curtains for the rest of your organs. So, in short, if you find yourself playing astronaut without a spacesuit, it's game over pretty quickly. Did you know that space doesn't have any temperature at all? That's because the temperature is defined by the speed at which particles move and the amount of energy they have. In the true vacuum of space, there are no particles to move around, making it temperatureless. Of course, some parts of space are really hot, like areas around stars. But the further away you get from stars, the more spread out particles are, making those areas of space pretty chilly. Number 9 is our planet's shape. No, it's not flat, but it's not a perfect sphere either. Yeah, it bulges at the equator because of our planet's wild spin. It's like Earth is doing its own little dance. And because of this bulging, launching spaceships from the equator is much easier than from the poles. Now, when it comes to sound in space, it's a bit of a tricky situation. You might think that no one can hear you scream, but that's not entirely accurate. The thing is, sound needs something to travel through, like air or water. In space, things are super spread out, so all those epic space battles and galactic explosions would be completely silent. Yet there are some places in space with enough particles for sound to travel through. For example, you can hear the black hole at the center of the Perseus galaxy cluster. Another myth is about zero gravity. That's not a thing. There's still some gravity hanging around the International Space Station, about 90% of what we feel on good old Earth. But astronauts get to float around because they're basically free-falling around the planet. And let's be real, Hollywood's version of space travel is not factual. Sure, orbits are a thing, but different altitudes mean different speeds. So moving from one orbit to another isn't exactly a walk in the park. You can't just push yourself in the right direction and hope for the best. You gotta take those orbital velocities into account. This reminded me of the 2013 movie Gravity and how Sandra Bullock tried to survive in space. Hollywood sure added some fuel to these myths. Yet again, who can blame them? Back in 1976, NASA's Viking 1 spacecraft snapped a photo of a curious rock formation on Mars that looked suspiciously like a face. Some folks out there claimed that it must have been proof of extraterrestrial life on the red planet, but NASA had a different take. According to the space agency, the face was nothing more than a bunch of rocks piled up in such a way that the shadows they cast created an illusion of facial features. It turns out it was just a regular hill that got a little too much credit for being photogenic. The solar system stays in place. Lie! It's zooming through space at a speed of 140 miles per second, which means that it's whizzing through the cosmos faster than a cheetah chasing its prey. It takes us 230 million years for the solar system to complete a full orbit around the Milky Way. It's a good thing it isn't getting a speeding ticket, because that would be one astronomical fine. Eh? Without the sun, planets would be pretty chilly. We're talking about temperatures as low as -455 degrees Fahrenheit. Brr. But with the sun around, the planets get to enjoy much more livable temperatures. Of course, not all planets are created equal. Mercury, for example, is the closest to the sun. Venus, on the other hand, is farther away, but somehow manages to be even hotter than Mercury. The distance from the sun isn't the only factor that affects a planet's temperature. Other things like the planet's size and reflectivity also come into play. So Mercury being the hottest planet in our solar system is a false proposition. No, just because it's the closest one to the sun doesn't mean it's the hottest. Even though we've been deceived in some ways, that doesn't make space any less amazing. It's still a vast, beautiful, and utterly fascinating part of our universe. And there's still so much we have yet to discover. Who knows, maybe one day we'll really discover little green people out there. Or maybe we'll find out something even more incredible. Until then, we'll just have to keep dreaming and exploring. There, you got 14 things on our list. Do you have any other space myths to debunk? We interrupt this program to bring you this important message. The Earth is no longer fit for living, so you'll need to find your own new home. you immediately get the brilliant idea to apply for a job as an astronaut. You'll be able to wait over the hustle and bustle on the International Space Station until humanity finds a new home, right? The longest time a human has spent in space so far is 437 days and a few extra hours. And when I say in space, I mean the ISS, because a human being without the proper equipment in open space would only last a few seconds. The ISS is designed to support human life in space for extended periods of time. Extended, but not endless. The station gets resupplied with food, water, air, fuel, scientific equipment, and other necessities every 3 months. With no Earth or humans to send the mission, this lifeline will soon be broken. The station is a huge ship moving through space at over 17,000 miles per hour. It faces pretty harsh conditions, from radiation to micrometeoroids and huge temperature ups and downs. That's why the system regularly needs patching up. In addition to wear and tear, there are also unexpected events that can require resupply missions. In 2020, the crew discovered a leak that was causing a gradual loss of air pressure. They eventually found cracks in one of the modules. The crew managed to fix it, but it proves how important it is to have enough spare parts on board. Let's say the future humans will manage to find a way to run the station non-stop without restocking. Astronauts already grow plants in space in closed boxes with low-energy LED lights. It's not only a source of vitamins, without which humans can't survive, but a great mood booster. We'd also need more advanced closed-loop life support systems to recycle air and water efficiently. It's a system that captures carbon dioxide from the air by passing it through small beads. Then it uses steam to separate the carbon dioxide and transform it into methane and water. Water then divides back into oxygen. But even with all the possible advances, there's another problem: the health of the astronauts. They live and work in a microgravity environment, and they rely on carefully controlled life support systems. But our bodies aren't designed to live in weightlessness forever. It's like standing on your head, because the reduced gravity makes bodily fluids accumulate in the upper parts of your body. The result is a puffy red face. The gravitational force on the ISS is weaker than on Earth, so muscles don't have to work as hard and bones gradually lose their density. That's why each crew member follows a strict daily exercise routine. The heart muscle also weakens because it doesn't have to use as much effort to circulate blood throughout the body. Without Earth's protective atmosphere, astronauts are continuously exposed to cosmic rays. They are invisible waves that can cause some serious health issues. So maybe we're better off opting for Mars or the Moon for an alternative.
You're relaxing in your room and streaming some good tunes when suddenly the network's down. You try rebooting your phone, but there's still no connection. Out of nowhere, your sister barges into your room in panic. She's screaming something about rings. Boxing rings? Wedding rings? Rings on the tub? She's not making any sense. So she drags you out of the house and shows you the sky. You take a look up and see streaks of objects forming miles above the Earth's surface. Her connection seems to work. The two of you check online what's going on, and everywhere the same thing is making headlines. Rings are suddenly appearing in our sky. Hashtag Earth Rings is breaking the record, and videos are going super viral. Your sister can't help but join the crowd and takes a bunch of selfies with the sky. You run to the TV in your living room to check out the news. Scientists are warning about a coming catastrophe and explaining that everyone should remain indoors. Even though it's a cloudless day in the middle of summer, the weather seems to be getting colder and colder. Suddenly, the signal's cut off. Other channels show nothing either. Then you see your neighbors packing their bags and heading out. Others follow suit. You hesitate a bit, but decide to do the same in the end. Your sister is still outside taking selfies when you urge her to come along with you to seek some answers. The two of you hop in your car and drive out into the city. The rings above seem to be gaining more mass with each second. You and your sister are getting colder and colder. You head to the university to see if anyone knows anything, but there's no one there. Only one parked car in the lot. And it's a good thing you recognize that car. You and your sister rush in and find the astronomy professor doing some quick calculations and trying to figure out why all this is happening. He urges you to take seats and begins explaining. No one knows what this is all about, but it's limiting the sun's exposure on Earth, which explains why it's getting colder by the minute. Why the rings are getting thicker is a mystery too. On Saturn, the rings are made up of ice and rock particles. They can be as small as an ant or the size of a bus. The rocks could be leftover meteor debris or even remnants of dwarf planets. But since Earth is so close to the Sun, ice wouldn't be something you'd find floating above us. With all these rocks piled up, they block the Earth's access to Sun to warm us up and give us light. The professor goes on to explain that Earth will enter a new ice age, and oxygen levels will deplete within a year's time unless those newborn rings disappear anytime soon. This also explains why there's no connection. The rocks that form the rings are hitting and breaking the satellites. Suddenly, you hear a loud ringing noise outside. The three of you head outside and see a helicopter blasting an alarm with a red light flashing. Everyone to your homes now! This is not a drill! Everyone, head home! You get in your car with your sister, but the roads are jammed. You have to go on foot, which will take 2 hours. There's no way anyone can remain outdoors. You venture out seeing everyone stuck on the road. They're all arguing with each other and causing chaos. You try not to get caught in the middle of anything and sneak your way to the highway. With the rings getting thicker, less sunlight is breaking through. This ice age info is stuck in your head, chilling you even more. You take a deep breath and see a thin mist coming out of your mouth. The sky is getting darker and you're still not home yet. Your sister is tired and needs to rest, but you urge her to move on. You find an abandoned clothes shop and head inside. The store clerks are actually giving away thick jackets for everyone to wear. You grab a couple and slip them on. Only 1 more hour to get home, but the sky is completely dark. There's no way you and your sister can go out in such conditions, so you decide to camp up in the clothes shop. They set up a mini bonfire in the middle of the shop and create makeshift sleeping bags with the rest of the unused clothes. Luckily, there's enough food to feed everyone, including you and your sister. It's the middle of the night. The fire goes out and you can't see outside the shop. You head to the window and open it up. A huge pile of snow spills in and wakes everyone up. It's the middle of August, and a snowstorm formed overnight. Everyone is freezing, and they start the fire anew. There's no radio or any way to find out what's happening. The wind picks up and starts shaking the shop. Things start falling off the shelves, but you and everyone else are cozy by the fire. The next day, you look outside and see the entire area covered in snow. You live in a sunny place where it barely rains, and the rings in the outer atmosphere are even bigger than last night. Out of nowhere, a truck filled with people pulls over, and the driver tells you there's a shelter for everyone some miles away. The truck has chains all over the tires and is equipped for the worst snowy conditions. Even though it's morning, the sky is pretty dark. You and everyone else hop in. Abandoned cars, some with their doors still open, are scattered all over. The truck drives around them or just smashes through the ones in the way. It pulls over next to an ambulance and takes all the equipment to help the ones in need. You drive past your neighborhood and see your entire house covered in snow. The large tree in your backyard has fallen under the weight of the snow and broken the roof, allowing snow to flood in. The truck speeds through and gets to the shelter, which, to your surprise, is the mall. You get out and see many of the townspeople being led to various stores that have now turned into dorms and health units. You're left in a sports store with a bunch of other people. Your sister has also been able to bunk with you, and to your luck, you see the professor helping out some people. But shortly after that, a loud explosion blasts through the mall and shatters glass screens. Everyone ducks for cover. You see people running outside. You head out and see a large metallic object lying in front of the mall entrance. There are people crowding the entire area, so it's not easy to see what all the fuss is about. But after getting a closer look, you find out it's a satellite fallen from orbit. It crashed in the front yard and made the boom. There were also reports of other satellites crashing on Earth in the most random places. That means all communication has been wiped out of the map. You run back inside the mall to await what happens next. You look at your sister in fear, not knowing that the new ice age has just begun. 1 year later. You're relaxing in your bunker when your sister barges in, freaking out. The rings are still there, but it's something else now. You run outside and see everyone gathering around and looking at the sky. Within a year, temperatures have dropped to freeze the entirety of the Earth's surface. Deserts and tropical jungles have turned into icy wastelands. More than half of the wildlife went extinct, and trees are as rare as a four-leaf clover, which means oxygen levels have dropped significantly. Most of the population, or what's remaining of it, live with oxygen tanks, with scientists still trying to crack the case of the rings. Exactly what the professor predicted. But up in the sky, rocks seem to be falling down and crashing all over. It starts off far away, but then the rocks begin to fall down close by. You and everyone else run back into the mall, which has been covered with a layer of metal to keep the warmth inside. It should be pretty safe in there. If the rocks are falling down, that means the rings are dissipating. Suddenly, you're full of hope that the Ice Age might be over soon.